Okay, so this is college algebra, and we are in 4.1, and this is the first video. There's just a picture of me looking off my front deck, just to give you an idea of where I'm making these videos. I'm on an island out in the middle of Ski Lap Lake on the Kenai Peninsula, and up on a hill we have a cabin that started out as just a vacation kind of place that we had dreamed about for years and years, and as we got money together we'd put it toward it, and well, we sold our house on the mainland and now we live 6 months out here on the island. So anyway, haul our water up from the lake, we run our electric off solar and a generator, and life is good out here. Fortunately, I have internet access and I can use my iPad and make these videos from out here. So here I am out on my front deck making these videos. So 4.1, first video, which this is 4.1a, because we will be going into more than just one video, just like every other section that we've gone in, because this book just seems to cover a lot of material in each section. So this particular section is transformations of graphs and symmetry. So let me get a graph on here for us in a second. Okay, so I had turned my internet off, so I'm just going to have to hand draw one of these rather than import a picture. But in the parabolas that we've done before, a parabola in regular old standard form looks pretty much like that, where the vertex goes through 0, 0, and it reflects across the y-axis so that we have the same distance here as we do over here, although my graph doesn't necessarily show up that way. And what happens is sometimes this graph shifts around. So let me bring in, there's a better graph there of what we're talking about. So if my graph, my vertex, my h, my axis of symmetry is the y-axis, and everything is the same distance on either side of the axis of symmetry, everything is well and good. But sometimes things shift. Sometimes things move, and oftentimes this parabola will move. In this case, it moved to the left, and it moved up to where this vertex is. So it shifted to the right, and then it shifted up. Now, these parabolas can shift to the left and shift down and do all kinds of stuff there. They can also do a couple other things. They can stretch, which means that they can become more like that, to where they stretch. They can compress and become skinnier, and they can reflect. So let's say that this blue one reflected to the other side across, oh, if I can get my pen to right, across the x-axis. Or sometimes, let me get rid of all this junk, sometimes we have our graph here and it will reflect across the y-axis and then be over here. Sometimes it can reflect across the origin, and it just kind of moves 180 degrees here, and it ends up looking like that. Okay, so there's lots of different ways that this graph can move around, and you can figure it out of what's going on when you have things in the form of y equals a times x minus h, the quantity squared, plus k. Remember that from last section or last chapter or wherever it was? So you can put different numbers in different places here for the a and for the h and the k, and make some adjustments here, and your parabolas, or whatever it is you're graphing, will move all over the place. Okay, so that's what we're going to look at in this section. Okay, so for example 1, they're doing a shift of functions and they're using absolute values. I'm not really sure why they're using absolute values. Absolute values can be a little tricky for some students, and so now we're in this new stuff using absolute values that are sometimes tricky. But what they want to do, if you look at the top of page 247, right-hand side, they have a blue graph and a red graph. And notice the blue graph is this one right here, which I'll do it on my right here. There's the absolute value of x, okay, the function of that. When we do the same thing, when we make our x and say in this case g of x, and we say that x is 1, g of x is 1 plus 4, say x is negative 2, g of x is 5, and we get a whole bunch of information there, and we end up with a graph that's right there, which means the graph has shifted up 3 spots, okay? So we shifted it up 3 units. So therefore, if we have a graph such as the one we have here, let's say this is middle of page 247, the vertical shift, up or down, it's going to shift this much k units. Okay, so if you are adding a number to your function, it's going to shift up 2 units. If this were a negative k, it's going to shift down. Okay, so this is up if it's plus, and if it's minus, it's going to go down. Okay, so that helps you to get an idea of what's going to go on here, and we'll give you some more examples here later on. Okay, so now looking at the same kind of thing, let's look at the shift of functions in a horizontal way, which means that if we have our absolute value function, and let's do it in blue again, okay, and if we have a graph with it like that, and let's say that this is 5 over, all right, so we start out at the origin and the new one is 5 over. What we've got is we started with, again, the absolute value of x. But if we take that absolute value of x, oops, that's an absolute value sign. If we take that absolute value of x and within the absolute value sign subtract 5, that is a shift left or right. Okay? So we're not adding, like in the last one, we were shifting absolute value of x plus 3. So outside of the absolute value sign, we added 3, and it shifted up or down. Well, now we are not adding something to the absolute value sign. We're adding something within the absolute value sign. Okay, and again, the absolute value sign just kind of makes it rough. But we'll get into some examples, and hopefully it'll clear something up. So really what they're doing here is they're saying, if we add something to the original function was just the absolute value of x. So now what we're doing is we're adding or subtracting something within that absolute value. So what they've got on page 248 is they say, okay, so we've got this function, and we are going to take our original function, which is f of x, so we're going to stick a number in there. We're going to subtract h from it. And that's going to shift right. Okay? It would appear that because of that negative, it would shift left, but it does not, and we'll get into why that is later on. Just remember, put that in your notes, that if it's a minus, it shifts right. If it's a plus, it's going to shift left. And again, the reason it kind of goes goofy on you is because of the negative signs. You know, 2 negatives is a positive. Positive, it's got, you know, goes right. So anyway, later on we'll get into more of that. But that's why. It's just because of the double negative part that's got things kind of a little goofy. Okay, so let's go ahead and look at example 3, and hopefully